Hello there, Algebra 1 students. Welcome back to another lesson in Algebra 1. This is Mr. Bean, and today we're going to talk about the quadratic formula. Some great stuff today. Very, very useful for a lot of things you're going to be doing in high school. Mathematics, in fact, this was one of the things that saved me on so many tests because I knew the quadratic formula. So I really want to emphasize focus and learn this lesson really well. You'll be very happy that you did. So first write down this quadratic formula, and that is that x equals negative b plus or minus square root of b squared minus 4ac, and then that whole thing is over the denominator of 2 times a. So what in the world is this thing as you're writing this down? This is how you solve a quadratic equation in this form. If you have it all set up where it equals 0, so when it equals 0, you can take the coefficients of each of these terms and plug it into this formula to be able to solve for x. Instead of having to do, instead of having to factor it, or maybe if it's not even possible to factor it, because sometimes it's not, because it's just too hard and too challenging. So what do these answers give you? These give you the zeros of the parabola. So the zeros, or in other words, the x-intercepts. So if you're thinking about the graph, if I have some type of parabola graph that's opening up, and then I have the x-axis, what this formula gives you is the x values of these intercepts. That is what the quadratic formula does. So without a graphing calculator, you could still get these answers. In fact, you can get them exactly with this thing instead of just decimals, which we'll talk about in a little bit. Okay, so it's very important that you are able to relate the graph to the quadratic formula for answering these problems. So something interesting about this quadratic formula, which I think is pretty cool, although some of you are going to be like, this is stupid, Mr. Bean, but I still love it, and that is if you take a parabola and you split it right down the middle, you get, what's this thing called? Mr. Sullivan taught us this. This is called the Axis of Symmetry. So remember how you had negative b minus 2a? Remember how we did that? X equals negative b minus 2a. That is the axis of symmetry. So what does it represent? The axis of symmetry. And I'm going to abbreviate with SYM, symmetry. So that's what the equation of this thing is right here. You could even write that this is x equals negative b over 2a. So from that, what does this part of the quadratic formula represent? Okay, so see what I've done here is I've just split it up into two different fractions. I put the denominator underneath each term. So this is equivalent to the above quadratic formula. So what about this portion of it? What in the world is this right there? That takes the axis of symmetry, and then if I figure out this distance right here, that distance is this. B squared minus 4ac over 2a. That's how far apart the axis of symmetry is to the 0. So in other words, we could say it's the x, put it in quotation marks, the x distance from axis of symmetry, and again abbreviating, and the zeros. So it's both directions, and that's why it's a plus or a minus. We add that distance to get to this 0, and we subtract that distance to get to that 0. Okay, that's what this is doing. So as we're using the quadratic formula and you're trying to figure this stuff out, just keep that in mind, that the quadratic formula helps you figure out the line of symmetry, and then from the line of symmetry, you're adding and subtracting a specific distance to get to the zeros. So kind of cool. Again, you're not going to be tested on that part of it, but you do have to have the formula memorized. So we're going to practice something to get this thing memorized. So look back up here at your notes. This formula right here, if you don't have it, you will get it memorized because you're going to use it over and over again. So I've got a song for you. Yes, a song. We're going to sing this together. I will start it off. If you remember the song "Pop Goes the Weasel," do 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 do, that song. So we're going to sing this to "Pop Goes the Weasel." Okay, ready? Watch how this works. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you got it? Now you can sing with me. Even if there's kids around you, you look so cool if you're singing a song. Ready? Try this with me. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, and we got to sing it faster. So you got to get this down really, really well. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you will get this when you're using it over and over and over again, like we're going to do in these examples, but you got to get it down. So for this first example, it would be much easier to solve this thing by factoring. Okay, so I'm about to write something down, but please don't write this. Don't write this. If we were to factor this, it would just be x and x multiply to 15, add to negative 8. That's going to be a negative 3 and a negative 5. Boom, we could solve it, get x equals 3 and x equals 5. We're done. That was really fast, right? Sometimes there are problems that are not easy to factor. And like number 3 over here, it would be a pain to try and factor this one. And so the quadratic formula would be much easier. So I'm going to show you the quadratic formula here, even though it would be easier to factor. So quadratic formula is just one more tool we're going to add to your toolkit of being able to solve equations, in particular quadratic equations. Okay, so what's a, b, and c equal? A here is the leading coefficient, which is a 1. B is a negative 8. And then c is 15. So now that we have those things, we're going to set it up in the quadratic formula. X equals, all right, I'm going to write out this big long fraction. So x equals negative b. What is b? B is negative 8. So that just means the opposite of b. So we're going to put an 8. So x equals negative b plus or minus the square root. And now I say b squared. So I'm going to put in negative 8 squared. Okay, let me make a note of this. Some of you are still doing this in your calculator and saying negative 8 squared is negative 64. Yeah, negative and then 8 squared is negative 64. That's because you do it wrong. You're supposed to do this, and that equals 64. Or just don't use a calculator and think about it. Negative 8 times negative 8 is positive 64. Sometimes we rely on the calculators too much, and it actually messes you up if you don't know how to correctly use them. All right, so just keep that in mind when we're doing negatives. This squared will always be positive. All right, now I'm going to say minus 4ac. So 4, and then what's my a? My a was a 1, and my c is a 15, and I am really going off the edge here. Hopefully you are writing smaller than me. I'm going to have to make this smaller in just a second. All right, and then all over 2 times a. Okay, let's make this smaller. Okay, that's better. All right, let's keep going now. So x equals 8 plus or minus. Now all we have to do is just simplify this thing. So this becomes negative 8 squared is 64 minus 4 times 1 is 4 times 15 is 15, 30, 60. 60 all over 2. So then we get x equals 8 plus or minus the square root of 64 minus 60 is 4 all over 2. And then we get x equals, all right, so then I have 8 plus or minus 2 over 2. All right, we're not done yet. Here's a big mistake that kids do. Please don't do this. Oh, hey, the 2's cancel. Don't do that because the 8 is also being divided by 2. You got to be real careful here. This is literally 8 plus 2. So 8x equals, whoop, switch back to blue. There we go. 8 plus 2 is 10 divided by 2. And x equals, now we do this subtraction. 8 minus 2 is 6 divided by 2. And we get, so my final answers are x equals 5 and x equals 3. So all of that work to get what we would have had in the first place from factoring. So this is a great example of a problem that factoring would have been a ton easier if you know how to factor. And it was a lot faster than to do all of this work. But it ended up working out nice and easy. So if you forget how to factor, quadratic formula will always work. All right, let's try another one. You know, I'm going to change this on the notes because I don't like having these numbers. So I'm going to divide both sides by 2. So your notes should already be set up like this. If I divide both sides by 2, I'd get r squared equals 3 minus 2r. Yeah, let's do it that way. Okay, so now if we have this, before you can solve this, it must equal 0. So let's set it equal to 0 first, because that's, if you look back at our beginning of our notes, quadratic formula only works if the quadratic equation is equaling 0. So you see how I did that? I added 2r to both sides, subtracted 3, so now I have this set up. Okay, so a is equal to 1, b is equal to 2, and c is equal to -3. So what I'd like you to do is try to solve this one on your own, and then I'm going to have the answer appear here with the steps to see if you get the same thing I do. Okay, there's my answer for this one. It's 1 and -3. You can follow my work here. What I did is I tried to highlight the part that was probably the thing that might trick some of you, and that is when you have the a or the c in this 4ac part, when one of those two numbers is negative, if one of them is negative, then this minus and that minus combine to make a plus. So you got to be real careful about that part whenever you see a negative. Now, if they're both negative, you'd have 3 negatives, negative, negative, negative. And that just stays minus. But when only one of them is negative, you'll end up with 2 negatives and you get a plus. I just said the word negative a whole bunch of times. All right, and then you just kind of simplify through this and get there. Okay, so it's important that you do try to show your work on these to keep track of everything as you're working through the problems. Now let's try number 3. This one's going to be much trickier because the numbers are going to be much larger. So first step is we've got to set this thing equal to 0. So let's see, I'm going to get 10n squared. Subtract this n over, I get a minus n, and then I still have this minus 21 equals 0. So all I did was set it equal to 0 by bringing everything over to the left side and combining like terms. All right, now let's see here. I've got a is equal to 10, b is equal to -1, and c is equal to -21. So the reason I chose an example like this is this one actually factors. We could solve this by factoring, but holy cow, this one's a bit more challenging to try to factor, and a lot more places where you could make some mistakes. If we try and multiply that thing out, figure out what multiplies to 10, 21, all that stuff. So let's try and see if the quadratic formula helps us out. And you probably want to have a calculator to help plug in some of these numbers. All right, so x is equal to, x equals -b, so the opposite of b. b is -1, so we're going to say 1. Plus or minus the square root of b squared. So -1 squared. -1 times -1 is just 1. Minus 4a, which is a 10, and c, which is a -21. Holy cow. Okay, so make sure you've got that negative in there. You got to remember that's going to affect this negative. So as you're going, you can just kind of think about that stuff. All over 2a. Okay, let's see what we can come up with next. See if we can clean this up a bit. We have x equals, I'm going to have this fraction here, 1 plus or minus the square root of 1 plus. Now, if we plug this in a calculator, multiply it out, that is 840. And then 2 times 10 is 20. All right, so do I know what the square root of 841 is? 1 plus 840 is 841. No, I don't, but I've got a calculator, so I plug that in and discover it's a perfect square. So it is 1 plus or minus 29. 841, square root of 841 is actually 29. And then all over 20. So then I get x equals 1 plus 29 is 30 over 20. And then I have x equals 1 minus 29 is -28 over 20. And then we could reduce those fractions or change them to decimals, whichever you prefer. This is 3/2. And this one is going to reduce if we divide everything by, what could we divide by? 4. If we divide everything by 4, it becomes -7/5. Some weird fractions here. And there's our answer. So you can see if we were trying to factor this one out, that would have been much more difficult to have come up with these answers. And the quadratic formula is kind of just, it's the same process over and over and over again. So there's nothing new to it. It's just plug and chug and then work your way through it. All right, 2 more examples and then we're finished with these notes. Now I'm going to talk about the difference between an exact answer and a rounded answer. So these 2 problems, if we go look back at the first 3, these 3 all came out to nice numbers. Some integers, some nice pretty fractions. These 2 examples will not work out that way. They're going to be some crazy fraction, or not fraction, crazy radical rational answers with decimals that go on forever and ever. So let's start off the same process we normally do, and that is we need it to equal 0. So I'm going to add 5x over plus the 3 equals 0. And then I identify what a, b, and c are. So let's see, I've got, I'll just do this right here. A is equal to 1, b is equal to 5, and c is equal to 3. All right, now set it up. X equals -5 plus or minus the square root of b squared. B squared is just 25, so I can plug that in right there. Minus 4, and then a is a 1, c is a 3, all over 2 times a. Okay, keep going. X equals -5 plus or minus the square root of 25 minus 12. 4 times 3 is 12. 25 minus 12. 25 minus 12. 13 all over 2. So this is my exact answer. My exact answer is, there's 2 problems, and let's do this. I could write this, but I'm going to separate it and say -5 halves plus or minus the square root of 13 halves. Sometimes this radical could simplify like what we practiced in 11.1 back in our earlier lessons. So we would try to simplify this fraction if possible. But this also allows us to see, okay, this is the axis of symmetry, and we're adding and subtracting this amount to get to the other zeros. Now, if a rounded answer means I want to see the decimal. So all you got to do is plug this in the calculator and get both of them. Remember, it's a plus or minus. So if I take -5 halves and add the square root of 13 halves, I get -0.697. I'll go out 3 decimals. And then the other one was -4.303. So the first one was if I add this fraction. The second one was if I subtract this fraction. That's where these 2 rounded answers. So these are the rounded approximations of the zeros, or the solutions to this, and this is the exact, because we're not rounding anything, we're telling you exactly where it is. Okay, so this is what you're going to do with number 5. I'll warn you on number 5, you're going to try this one on your own, but I will tell you that when you get to this step here, before you write it out on the exact, you are going to have to simplify this radical. So you're going to want your calculator to help you get this radical simplified as you're progressing through. All right, try that one out. This is the last one, and then I'll show you the answer here in just a sec. Okay, this is definitely one of the more advanced problems that you might see on any type of master checker test. It's probably as hard as it could possibly get, and that's because as you're working through this, there's several little tricks you had to recognize, and that was you had a negative and a negative here. Since the c is negative, it combines with this one to make it plus, so that gave you the square root of 396. I don't know what the square root of 396 is, so what I did with my calculator is I divided this by 4. I thought, it's even, maybe 4 goes in. So I tried that, and voila, it worked. I got 99, and then I broke up 99. So then you can simplify the radical. This goes back to some of our last lessons. Square root of 4 is 2, square root of 9 is 3. And then you separate the fraction. The 14 goes underneath both of these. So you can kind of see here my steps. And then I just simplified these fractions. So this is my exact simplified answer. And this, I took 1/7 plus this weird crazy fraction, and I got this decimal, and then I did 1/7 minus this weird crazy one, and I got -1.28. All right, there you go. Now let's just wrap up our lesson. So what I put on the end of your notes was just 3 things that are really important to remember because of the mistakes that students make all the time with this. I think if you had any algebra or algebra 2 teacher that said, hey, what do kids do wrong on the quadratic formula? These are the things where they mess up. So first thing is you forget to take the opposite of b, and I'm talking about this thing right here. It's -b plus or minus square root. So forgetting to put that it's the opposite of b. That's the first thing that the kids make mistake. The next thing is incorrectly squaring b when it's negative. I'm talking about right here when b is negative. Okay, so remember, I already talked about this, but if b is -2, then -2 squared is 4. This will always be positive. It's never negative. Okay, so -2 times -2 is not -4, it's +4. So just be careful about that, how you plug in things to square it. And then the last thing I put on here, one of the most common mistakes is, we talked about this, if you have either A or C, if one of those 2 numbers is negative, then it's going to create this to be positive. Okay, so b squared minus 4ac becomes b squared plus 4ac when the a or c is negative. So just be real careful about that. When you distribute it through, it becomes a plus. So if you had any questions on these are good ones to kind of star or write question marks next to. Check with your teacher to get this all figured out. And then the next lesson, we're going to do something called completing the square. It'll be one more thing on how to solve quadratic. So you have all these different ways to solve these types of equations. All right, rock that mastery check, and I'll see you back in the next lesson.